इसका मोबाइल बदलूंगी। आनंद, इसका मोबाइल।
Good evening, students. Good evening, students. Today our topic is learn about something ARM Cortex. Okay. This is ARM Cortex. ARM Cortex. So many families there like model LPC 2129, STM32, ARM 7. These are the models. Okay. These controller we can use industries, embedded, automotive, power management. We can use for the control for the signal processing capabilities. Okay. Now we see the STM Cortex M4 series. ARM is a processor. That processor family separate the STM Cortex M4, LPC2129. This is the family series. Okay. Now here see the STM32 F439. This is serial. Okay, this is format. Here separate is there like memory, I/O ports, peripherals, registers, protocols, everything separate. Okay. Difference ARM 7, ARM Cortex. Major difference. Uses both ARM and thumb2 instruction set. Here instruction set only available. Here ARM also available. Thumb instruction sets also available. Here only instruction set only available. This is the difference. This is founders NXP series LPC 300. These are all the series. Okay, this is CPU core. What type of the core? Cortex M3, M4, M0, M0 plus 7. ARM Cortex. This is ARM 9. This is ARM 7. These are all the NXP series. Okay. Now we can move about the STM32 series. Okay. This is series STM32 series 32-bit ARM Cortex M4 series. So many series is available. F4, F4, G4, A4, 11 series available. Here F4 mentioned F4 69, 29, 27, 46, 07, 05, 01, 10, 11, 112, 13. These are all the series. Okay. Flash memory. This is RAM. Architecture. This is CPU. One memory protection unit like ITM trace, ETM trace, DSP, FU, JTAG, serial wire, breakpoint unit, data watchman. Here interrupt controller is there. Here also one interrupt controller. Here backup interrupt controller. Here vector interrupt controller. Okay, this is architecture. Inside memory protection unit, DAP, data watch points, ETM, serial wire, flashpad. Here bus matrix, code interface, SRAM peripheral interface. Upside floating point unit. This is NVIC, WIC. This is architecture. Okay. Pinout. This is STM32 F4 pinout. Okay. So many series is there. STM32, F4, G4, A4. This is STM32 F4 series pinout. This is how many pin is there? Pin diagram. PA0, PA1, ground, power supply pin, protocols pin, SP protocol pin, UART protocol pin, analog pin. This is pinout diagram. Okay. This is data pins. Here protocol pins. This is power supply pin. Red color power supply pin. Green color protocol pin. Yellow color also protocol pins. Blue color data pins. Red color power supply pins. This is STM32 linker. Okay. Suppose you code once done, type the code means you can bootloader one STM32 linker is available. That is one, this one. Okay. This is STM32 pin diagram. This is architecture. This is serious. Okay. This is ARM Cortex family. Okay. Theoretical part understand everyone? Now move the practical part, coding part, right? Open the Chrome, install Tail ID. Okay, Tail downloads, product downloads. I am already installed. Product MTK ARM. This one you can install and download and install. Okay. Again, you open that Tail version. Here and save the codes. Basic LED blinking. Okay. Now open the software. This is LED blinking code. Okay. Before you can add the some library files, C files, header files. Okay. Here I mentioned. First of all, open the file. Before you can install the package. Okay. Which package we can use? Package installer. Here search. Now I am here using STM32 G4 series. Now install. Here search the here loading. Here search the STM32 here. Okay. Search the STM32. Here STM32 microelectronics term, right? Here I am used. These are the series F0, F1, F2, F3, F4. Now I am using G4. G4, so many series available. Here I am using 9.1. Here already come. 9.1 means here come. You just click install. This is the procedure. Board installing purpose. Now install means again you go to the project, new vision project. Open means here project name given means here come project. One target file come. Again you click means source file come. The source files you can add the source files. Now touch here STM32. This is source file. .h, .c, .h. These are the source files. Okay. Everything click by click you add it. This is source file. Okay. Now I am type the code. Before you can CM. CMs is you install. CMs is option the core option. You can choose the core and okay. CMs is means like controller environment. Okay. Common microcontroller software interface standards. Software interface for microcontroller. That purpose CMCs we can use it. Okay. Now this is the code. This is STM32 G491 header files. I am giving delay through the functions method. This is delay function. Now coming main function. Okay. First of all, enable the GPIO pin. These are all the register. Okay. Now you can see the register manual. Okay. STM32 manual. This is manual. STM32 manual. Register. Wo option the register. Here mention reset clock control. A gets to B ENR. And here mention 306. Okay. Here search 306. This. Okay. This is the A gets to BNR. Clock enabled register. Peripheral clock enabled register. That purpose. Now here I am enable for the port A. Okay. Here port A enable. Okay. Here port A. 0 means disable. 1 means enable. That purpose only here I am using OR logic. Okay. AND logic means 0 will come. 0 means disable. The port will be disabled automatically. We can use R means 1 come. Okay. 0 left shift 1. Okay. You can return the binary value for 0. Left shift for 1 position. Okay. Port enable purpose, this purpose, we can use this logic. 1 left shift 0. 1 means number, 0 means position. Okay. Now we can use that pin purpose, we can use output mode register. Okay. That purpose we can use MODER. That register we can use. Here manual purpose we can use MODER. Mode register. Which mode? Output mode or input mode? We can use. You see, MODER register. First of all, you arrange sets, okay? I think 355. 355. MODER register. Mode output register, okay? Now I'm see that reference one. We can see that register. Which function we can use for? Okay, now here see 355 like mode register, okay? Here search 355. Okay, mode register means output mode, okay? Here that mode we can clear. This is formula, okay? Clear a bit formula. Now I show the formula logic. Now that formula I'm sure, okay? Operator shifting formula, okay? Left shift, right shift. Okay, this is set a bit formula. Num equal to num logical or one left shift position. This is set a bit. Next clear a bit. This is formula. Num equal to num and complementary one left shift position. This is clear a bit formula. Here now I have mentioned clear modes. 5 into 2, 10, left shift 3. Here 3 number, 10 is a position. Now I am here, I am binary value I am writing. First of all, 3 binary value. Now 1 like 1 comma 1 0 0. This is binary value for 3, right? Here 1 2 4 8 3. Suppose let's check for 10. Up here 10 digit to mention. Like example 0 0 1 1 again 0 0 0 0 4 0 0 0 0 0 0. This is the final value. 10 bit we can left shift. Here 4, here 8, here 10. 10 bits. Okay, this is actual value. This is 3 number. This is position. Understand? MODR register, mode register. Okay, this is set a bit formula. This is complementary means ones and zero and ones. Here output when coming, suppose 11001111 space 1111. This is output. This purpose. Here set a bit means 5 to 10. Now 10 one position. Okay, one left shift. Suppose answer 0001. This is binary number for 1. Now 10 left position. Now answer is 1000 0001. 10 left shift. 0001. 0000. This is one left shift for 10 binary number. Okay, here R logic using. This is 10 left shift for 1. 10 is the position, 1 is the number. You understand or not? Next, this purpose, port A I mentioned for the output type. This is port type ER register means here you see O type ER register. Output type register. Okay, that purpose, that port input or output here mentioned. That purpose is here using output type register. Here you see 1 left shift for 5. Here 1 is the number, 5 is the position. Okay, same pull down. This is pull down register, PUPDR. Here you see PUPDR. Pull up, pull down register. Okay, here where 5 into 10. 10 into left shift for 3. Okay, pull down register. This one. Here logic. GPIO ODR. ODR means output register. 1 left shift for 5. Already that purpose 0 is there. Toggle means 0 means 1, 1 means 0. Here while condition. Condition true means automatically 1 0 coming. That time LED will glow. This is logic for LED blinking. Understand? Understand or not? This further, this is LED blinking coding. Now I am debug the code. Here build. Here 0 errors, 0 warning. Now I am connected for the STM32 microcontroller. Connect for the via USB port cable. Now here suppose you USB B type cable connections, that option will come. Node G4 91RH series. Okay, you can minimize. Now here debug. Now here an option is there. Here linker debug option, ST link debugger you can choose. Here path also you can choose. This path only. Now I am okay. Here I am run the code. Okay. This is run option. Now here code will running. Okay. Here you see means STM32 board you see means LED right side LED will be that board. I am show the code purpose and show the board. STM32 G491RE. This is the board. Okay, this board only. Here show the board. Here is the LED. This LED will on and off. Okay, this is push buttons. Okay, pin, which pin means here connected? PA5. That pin only LED output act. Okay, now here I am stop the code. And stop the code. Okay, this is run option. You understand or not? LED blinking code. Suppose you can any sensor interface means that value you can watch means here window option, one option is there, view. Watch window, one option is there. Okay, these are the LED blinking code, embedded code. Okay, first of all you Developer code means you learn C. Okay. Next, STM32G4. Which series means that series user manual you can learn. This is STM32G491 RE user manual. Now again, I am open the ultrasonic sensor. Now here ultrasonic sensor code is there, right? Okay, this is the ultrasonic sensor code. This is header file, STM32 header file. This is STD1 means standard input output header file. These are all the volatile keyword use, start time, end time, duration, measurement, distance. Everything is need. I am here declared for static keyword. This is function for prototype. You what init, character, string, system clock configuration, GPU init, timers initialize function, trigger for ultrasonic, exit for IRG handler. Okay. This is delay functions. Delay function we can use timers register. That register here I am mentioning. Now main function. Here system clock configuration function call, GPU init function call, timer init function call, evot init function call. Here I am send the string system core clock. Here I am printf buffer system core clock. Next evot for sensing buffer. Next ultrasonic initialize star. Here measurement. I am calculate the measurement. Distance equal to duration divided by 58. This is formula. Okay. Embedded that ultrasonic standard formula. Arduino means difference. Distance equal to speed unit time divided by 0.043 divided by 2 semicolon. Here this formula. Okay. Next, I am mentioned here delay. Next, you what init function. You what init means here I am mentioned RCC AX to BNR. Like port enabled register, that register AX B to ENR. Here output or input here register GP IOA MODR register output mode. Here I am using AFR. AFR. register. That register we can use. Now I see the AFR register. Here you see AFR register. Here where mention AFR, here mention AFR register 359 359. AFR, okay. Here that purpose only. Here mention AFR register. That register what purpose you can use? AFR means alternate function low register. Alternate function. AF0, AF1, AF2, AF3. Alternate function. Okay. Here which function we can use? AF4, L3, L2. Here. Here where AF4, L3. This is L3. This is L2. That register here register. Alternate function register. Okay. Now here you want port 2 enable. System 4 clock baud rate 9000. You want baud rate 9600. Here I am using volatile keyword. Volatile means variable unacceptably change means here tell the compiler no change. Default variable mentioned means that purpose we can use volatile. Here I am using for loop int I equal to 0, I increment 1000, comma I plus plus. Next word function send character, one character and send the character. Here string also I am send for the string. This is clock configuration. Everything registers only. Okay, RCC reset clock control register. Here I am GPU init function. PA0 output means MODR we can use. Input means POPDR. Setup for PA1. That purpose we can use this register. Here timer init function. Timer register. Trigger for the ultrasonic sensor register. Next finally IR handler like interrupt handler. That register we can use. Okay. Finally here clear the function. Now I am interface the ultrasonic sensor. Ultrasonic sensor pin out. Now you see ultrasonic register. Sorry, ultrasonic sensor. This is ultrasonic sensor. Here 4 pins available. Trigger, echo, ground, VCC. This sensor, what purpose we can use means distance calculating purpose. Now we'll see the code. Here trigger A0, echo A1. You connect the A0 trigger pin, echo A1 VCC ground. Now I am build the code. 0 errors, 0 warning. Now I am run the code means start the debug. Code will be debug. Okay. Here distance. Okay. Like watch one. Now I close the watch means here watch window. Watch one means which variable. Here I mentioned distance centimeter. Here also that purpose only I mentioned. Suppose you connect the ultrasonic sensor means here measure the distance centimeter purpose. Okay, this is ultrasonic sensor code. Same procedure every sensor, ultrasonic sensor, IR sensor, LDR sensor, soil moisture sensor. So many lot of sensor is available. Totally 3000 sensor is available. Okay. Understand or not? Everything is understand, right? Any doubt? Like LED interfacing, ultrasonic sensor, coding purpose. You fully typing the code means you learn for the C and the STM32 reference manual. Everything register only. You must learn for the like operators. Like assignment, arithmetic, relational, logical, bitwise. First 5 operators you must learn. Last 9th one, increment or decrement operator. Okay. Mostly we can use embedded C bitwise operator only. Left shift, right shift, and or logical or toggle complementary. Okay. This operator mainly used for the embedded C. Next, set a bit, clear a bit formula, you know, must. Here I mentioned set a bit, clear a bit formula. Here I am show the formula. This is set a bit formula. Num equal to num logical or one left shift position. This is set a bit formula. This is clear a bit formula. Num equal to num and complementary one left shift position. Okay, clear a bit, set a bit. Okay. So many like you first of all know the difference between processor and controller. Processor means we can do the multiple tasks. Example, in your mobile phone is there. Same time you read chat and playing the game. But controller we can use for the specific task only and simple task. Like example, AC, fridge, washing machine, everything do the simple task only. Okay. And mainly another important point, processor we can use the storage purpose. Add means extra we will add. Controller same single purpose only. We cannot add the storage purpose. And CPU, RAM, ROM, timers, floaters, peripherals, everything separators only for the processor or controller. Everything inbuilt only. Peripherals, ports, RAM, ROM, CPU, everything inbuilt only. Okay. Next, has any doubt like LED blinking ultrasonic sensor codes? We can use another software STM32 Cube. This is STM32 Cube. Suppose you can use STM32 Cube means you put it the logic only. Everything will come like clock configuration, pivot initialization, everything will come. You simply write the logic only. This is STM32 Cube. Okay. Now I am fire sensor. This is LED. Now loading the code. Okay. Everything will come here. Write for the main logic. This is pinout diagram. Which one we can view? This is pinout diagram. Next clock configuration. This is clock configuration. Next control F means like you generate the code means this file will come. Main say here, here, there. While here only use for the written for the main code. Here system clock configuration, interrupt handler, GPU unit function, everything will come. Okay, header file, everything will come. This is STM32 cube. Okay. I am using for the Kale ID. Okay, you understand or not? So many series available. Founder for the NXP Philips. Okay, ARM Cortex family. Now I am using STM32 G491RE series. This board only. This board. Everyone install the Kale IDE. You practice the embedded C code for the development for STM32. Most of the company asked for the STM32 development code. Okay, controller. You install the Kale IDE and practice the code and debug the outputs. Okay. These are all the functions. You want init function, you want character function, string function, clock configuration, GPU init function, timers init function, ultrasonic functions, interrupt handler functions. The functions, everything here I mentioned further through the register I am explained. MODR register, AFR register, APB LENR register, USART to enable register, everything here. We first of all learn for the reference manual. ODR means output data register. O type ER means output type register. MODR means port mode register. This data set, we can learn the data set. Same time to add the source code, add the source file. Here source file, one file is there. Here now I start the code. Now I am running the code means now I am debug the code. You don't forget, you must the CMCs, like controller, microcontroller system interface configuration. Like 4 you can choose and okay. This is LED blinking. I am giving time the 5 minutes. Note the LED blinking code. I am give the 5 minutes time. To note the LED blinking code. Guys, fastly note the code. LED blinking code or STM32. Everyone note the code. Everyone note the code for LED blinking and practice. And show the code and you type the LED blinking code. This is LED blinking code. I am giving the 5 minutes time to note the LED blinking code. Everyone note the code. Okay, good. Rohit. Understand or not? Like LED blinking and ultrasonic sensor code. Yes, give me reply. Understand or not? LED blinking ultrasonic sensor code. First of all, you understand mean. First of all, you learn, see, and reference manual. That purpose only you can learn. Okay. Otherwise, it is a difficult one. Finish the LED blinking code. And copy and give the chat box. Okay. You do it. This is LED blinking code. You can do it and buy the one STM32 G491 RE series. This board you can buy and do it practice. LED blinking. LED will on and off. You can check. Okay, STM32. This series you can buy. Okay. Theoretical but understand guys. Like STM controller means what is the controller, difference, how many series is available, STM32 series, architecture, pinout for STM32, this pinout different, STM32 F4 pinout, okay. Here I am seeing for this STM32 G491, this pinout I am show the STM32 G491 pinout. So this is STM32 G491 pinout. This not for this is G4 here there G491. This is G491 pinout. Okay. Everyone understand or not? So coding part, practical like theoretical. You properly understand means you do the practically. Okay. Just you see means no not understand. You do the practically. Now I am sending the LED blinking code. You install the Kale IDE and do it practice. That purpose only you can understand. Okay. Most of the company asked for the one development board, mainly STM32 asking. As understand? Like interview purpose. Any doubt? No doubt means you can leave it. Okay. Thank you. Rohit Roshan. Do it practically. That purpose only you can understand. I am sending the LED blinking code. You install the Kale IDE and do it practically. That purpose only you can understand. Board series also here I am mentioned STM32 G491RE. Okay. That purpose only you can understand. Okay, thank you, Pa. Ishan Rajvanshi. Some of company, like mainly company asked STM32. STM32 knowledge. You can more learn for the STM32. Like bit shifting and registers. You can learn for the STM32 reference manual also. Thank you guys.